Hey friends, are you familiar of this place? Any guess? It's KFC China. What about this integrated development environment? This modular boards? Are you familiar? Which circuit do you think it is? I will tour you into a shallow dive about the topic we will discuss today, which is a continuous topic of the thread. Automated test equipment, or ATE, the date project created by Dandy dedicated for testing Class D amplifier. Hello everyone, my name is Sheila, your friendly AI. I wish everyone is in good health while watching this video. Alright guys, let's dive to the project. Obviously, this LCD display tells already about the project. It is an Arduino project called AATED. And it is obvious also who made this project. You can see the design files and the LCD display. Yes, the one and only, the sponsor of this video. I would say, the maker, the DIY guy, educator, audio hobbyist, and one of the creator of the Class D amplifier project. This project is called the Arduino AATED Test Equipment for the Class D amplifier created by Dandy team. It is specific to Arduino solution, the term solution composed of hardware modular board called Shields and Sketch.
I'm here at KFC and I'm defining the features of the Arduino automatic test equipment, and at the back of the KFC I got here the definition, features, and what should I do for this project. Where's my coffee? I have to get my coffee. A2TED, that is defined for Arduino automatic test equipment for the DR100W concept project. So that's gotta be the official name, A2TED. So for the AATED, I'm going to implement a simple project management to guide me, or maybe somebody will going to join me for the development of this project. Then we have a guide toward a successful project.
It's really noisy at KFC. I guess that it's Chinese favorite place and there are more people there. What Dandy trying to say is that he will calmly define all the paperworks. He will not start to rock and roll in the bench test right now. He will also going have project management for this project, one of the tool he is using for a successful project. A KPI other maker or hobbyist is using in his project. He then tried to share the MMI through discussing the block diagram.
Let's see the temperature and humidity module, the DHT11, which is located at the left side of the Arduino Uno.
The block diagram on the left composed of sensors and relay hardware, while the block diagram on the right composed on the man-machine interface hardware like LED, LCD, buttons and buzzer.
The temperature module 1, or TM1, is based on DHT11, which can read the ambient temperature and the humidity, which is connected to pin 5.
He continued to explain each of the block on the sensors and relays and me, but it is definitely a boring things to listen. So I requested Dandy to share his defined features in PDF format so anyone who are interested can download it. That would be awesome.
Let's see the working prototype based on the Arduino Uno plug-in pre-hardwares. This composed of the ATE. Just for the record, this is the humidity and temperature sensor, this is the RTC, the LCD, this is the tact switch, the LED, the buzzer, and this is the relay, which is used to control the power supply of the unit under test. This one here is the unit under test, which is the DR100W concept control module, and it is powered by a plus 5 volts power bank. We are missing one module, which is this one. This is the LDR, or the light depender resistor module, which I put it in here and I cover it with the masking tape. The function of this module is to detect the backlight of the LCD module. Let's see the MMI. This is the standby display, and when I push the text switch, this is the selection. We have the AATED menu for today, and you can actually select and number 2 is blinking now. Number 3 is blinking, that is the test case number 2. And if you press once more, then you go back to menu number 1, which is the power and off cycle. If you want to test power and off cycle, which is number 1, just keep pressing this for about 4 seconds, and there you are. This is the AATED run or the execution menu. Alright, let's see the...
Oh my god, what was just happened?
Oh,
This is real
is it
video
broken?
vlogging. It is not
Oh.
easy.
This tripod here is no good. How could it be? My goodness. Let's see the behavior of the unit under test when the ATE will power it on. Press and hold for 4 seconds and we'll execute. Now it's powering on, system on, and the LDR there is checking the backlight. Now the ATE is checking the backlight off. The unit under test is now in the standby mode. Oh, sorry for the reflection. And the backlight will turn off after 5 minutes. So the ATE is now checking when is the backlight will be turned off. By the way, this is the real time right now. It's at 3 o'clock in the morning. I'm still working on here. It's Saturday, so this is the only time that I can able to work. Yes, we need to wait for 5 minutes before the unit under test is turn off its backlight for the power saving mode. The elapsed time is 3 minutes and 32 seconds and counting. And the time now, the real time, and the ATE is 3:11 in the morning. UT turn off the backlight. That's it. And the UUT and or the ATE will sense it and it says success. And this is only for 2 cycle, and it says test end, and it was a success test. There is no any error.
Speechless people. You can see how hard it is to make this video. Nearly broken the phone camera and shooting this video at 3 o'clock in the morning when everybody is sleeping well. It's because of that passion to share the project that can be fun, self-fulfilling, and a part of Callus idea that is collaborate, avail, learn, access, share, and support. Please friends, show your support with your subscribe, like, and share all his videos.
This is the power of the unit under test, so I can simply unplug it, assuming that there is something on the UUT, and I'm going to execute the ATE and choose number 1, the power on off cycle. Alright, it says checking the UUT, but there is no really response on it because the power is removed, and the relay in there is actually a closed circuit, but there is no DC power. So let's see what happened. It says error and keep beeping with the buzzer, and the LED is also beeping, and you can see that the error is 01. Let's see the scenario that the temperature in the surrounding suddenly changed, just like something is going on, like fire, or the system is overheating. So I'm going to use a soldering iron to simulate the situation that the surrounding is getting hot, just like something is burning. The temperature goes to 40 degrees centigrade, and there you are. The system detected. It says overheating, and the error is 02. It's Ferdinand and you once again, and I'm back into my board with the timing diagram of the test number 1, the power on off cycles, and here is the black diagram of the AATED controlling the DR100W concept product. Let's reverse the camera. Let's have a quick review of the timing diagram of the test sequence number 1, which is the power on off cycle. Let's start with the sequence number 1, that is the timing diagram for the relay, and sequence number 2 is the backlight status, that is in the red color, and sequence number 3 is the timing for the LDR to check the backlight. So in a simple way, the relay, that is the relay switch, will power on or supply DC power to the DR100W concept project, and once it kills the power, then the LCD will wake up and it will flash, that is the MMI for the LCD, and the blue color, which is the timing for the LDR, will check if the LCD is lighted up or wake up by monitoring the backlight. And in here, after 5 minutes, where the DR100W concept will goes into the power saving mode by turning off its backlight, then the LDR again will monitor the turn off of the backlight, and after that the relay will disconnect the DC power to the DR100W concept. That is one cycle, and one cycle is roughly about 6 minutes. In a critical product reliability, normally they test the product by powering it on and then powering it off for 1000 cycles or 1000 times. And in here, my computation based on this timing diagram of one cycle is that one cycle is 6 minutes, 1 hour is 60 minutes, and we have 10 cycles in 1 hour. So if we have 1000 cycles, that is 1000 cycles in 1 hour, we get 10 cycles, and that is 100 hours, and in 1 day we got 24 hours. So we consume 4.1 days to test the DR100W concept. It's not a worry because the AATED here is can work 24/7, and as per our computation, it needs 4.1 days. If this timing diagram is not clear, then maybe this simplified black diagram is clear. So we have an AATED there, and we got the power supply of plus 5 volts, and the AATED is controlling the relay, which provide a plus 5 volt DC to the DR100W concept project. And once the DR100W concept project receive the plus 5 volt, then it turn on the LCD with the sequence of backlight, and that backlight is being checked by the LDR, and it reports to the AATED microcontroller, the Arduino Uno, its status. After that, the DR100W concept will goes into the standby mode, and the LCD will be turned off after 5 minutes. It will go into the power saving mode, and when it turn off the LCD, the LDR will know it because it keep monitoring it, and then after that the AATED will turn off the plus 5 volt DC, completely putting the DR100W concept project into deep sleep mode. And the cycle will repeat and repeat and repeat. What I have done so far is just a demonstration. I actually make it for us to show you the performance of the AATED project, which is an Arduino solution automatic test equipment. Of course, I can able to make more menu. Test case number 1, so I can generate that test case number 1, test case number 2, 3, 4, 5, depending on what I need.
I realized that there is actually a series of this project and published in Dandy personal channel called the D Steps. He also teach the art of Arduino programming. They're using his own design Arduino board and shields. This is really heart-touching. He is making this project while visiting Europe like France and Holland. Instead of enjoying the vacation, he is busy filming this project. I think that we have seen enough passion to share this project, and also other previous project like the Date project and the Digital Class D Amplifier project. Would you help him to do more videos of the art, adventure, and fun of do-it-yourself learning? That is a hard question to you guys.
And I do hope that you like it, you get interest on it, and if you are interested with this project, you can join me, of course. Welcome to join me, and we can make this project successfully.